Hey Dad. So I've expanded my computer a little bit. If you look right here, I've got my display. I showed you that in the last video. This is the B register and this is the A register, and this is the arithmetic unit. This is the program counter, which is literally just counting from 0 to 255 and then wrapping around. Right here we've got the data bus, and that's basically just 8 bits of information going this way, so every module can share that. Over here we've got the clock, and the new addition here is 4K of RAM and then the memory address register. And this was something that I came up with in the last few days. I mean, I didn't come up with it. It's a very standard design, but I didn't look at any schematics. I didn't look at anything. I basically bought these two right here, two 2K RAM chips, and looking at the data sheet and just trying to figure out how to implement this, came up with having a 1.5 bytes of memory address register. And basically the reason why it's a 1.5 bytes is because in order to access 4K you need 11 bits, which is one less than a 1.5 bytes. So I only had to do a 1.5 bytes. So basically I'm taking the address off the bus and putting it into the low byte first, so 0 through 255, and then committing that. And then the next thing that'll happen is on the bus will go the high byte, which is what is it, 0 through 8, 0 through 7, sorry. And that gives me all 4096 bytes available on these memory chips. I'll give a quick demonstration here if I can. This is a little bit manual right now because obviously I don't have the program flow going, but I'm going to set this clock to manual, and that'll let me step through it. So what I'm going to do first is I'm going to clear the memory address register. Everything else is clear. Everything's at 0. Set the counter to 0. I'm going to put the counter out onto the bus, and you can see right here that it's 0, and I'm going to set actually I just cleared it, so I really don't have to do that, but I can set the high and the low order memory address register to 0 just by putting them on the bus and cycling the clock once. So now they're both at 0. And then you notice I've got a 1 here. Well, let's go ahead and put that value into RAM at memory address 0. And so what I will do is I will take the write enable on the RAM, because the RAM is always connected to the bus. It's just open connected to the bus, and then I control what it's doing with the bus by either the, right here I've got an output enable, or right here I've got a write enable, and that means write to the memory. So if I turn the write to memory on, I don't even have to pulse the clock. I just have to set it high and then set it back low. And now I'm going to take the counter off of the bus, so the bus is showing we've got a value of 0 on there. Now, if all this works as I expect it to, I change this from read or from no output to output, and we have the value of 1 in the memory. And I can do the same thing over and over again. So now let's turn the clock on. Let's put the counter back out on the bus and turn the clock on, and let's just turn it up a bit and go to some random memory address, and that's good right there. So let's set it back to manual. Okay, so address 88. So I'm going to put the bus onto the memory address register low bit or low byte, and that'll put an 88. And you notice I've got some LEDs in there just for testing. So 88 is now loaded in the memory address register, which is connected to these chips, which is saying now point to memory 88. And I'll just go a few more counts up so we can put a cool number in. There's 95, and I'm going to put 95 into memory address 88. And that's done. So now if I take the counter off of the bus and put the memory on the bus, it should say 95 in address memory 88. Now that's cool and all, but let's go back to memory 0. Oh, we've still got our 1 there. So that is memory address 1, and then again, if I take the counter up there and reset the counter, turn on the clock, I'm going to get back up to memory address 88 and just make sure that we still have 95 in there. And so it's pretty cool, and I've got 4K of RAM. I've got nothing to do with it, but you know, hey, what, you know. All right, let's manually pulse the clock to 88. Okay, let's put that into the memory register. There we go. And we've got that same light lit up, even though it's only part of the byte. And now let's just take the counter off. Oh, there's our 95 again. So memory's working right. It's kind of interesting. I, again, don't have anything to do with it at this point. But as I build this out, I'm going to do some program control so I can do commands like machine language commands like load 95 into memory address 88. And basically what the way the command will go is load 95 into, or I'm sorry, load address 88 with the value of 95. So as I'm going through the bytes of the command, I will say load 90 or load memory address 88, and I'll put that into the memory address register because it'll hold that. And then once I'm done with that, I'll put the 95 out on the bus, and then I'll say, okay, now write, and then turn that off, and then it's available to do whatever I want to with it. Again, you know, it's a lot of fun. I'm learning, I'm applying myself, and it's a really interesting concept to actually be looking at how to build the computer that I used when I was, 14 years old. Because that's the Commodore 64. They actually sell these two chips right here. Like I said, are 2K chips. They sell 32K chips, and if I take two of those and put them here, add one more of these registers, add one more of the chips to the register, I could have 64K of memory on this computer. I thought that was a little overkill for right now, but if needed, I could literally just take out these two breadboards and replace it with a 64K memory module and get a 60K upgrade. And literally it costs the same price because the RAM chips are the same price. But it's fun. It's really interesting. It's gratifying. That's the best word for it. So anyways, thought you'd enjoy. Talk to you later.